the trigonometric functions, we're looking at cos theta. F of theta equals cos theta, or f of x equals cos x. So we're going to draw that function of cosine function. I have drawn this unit circle. That means the radius is 1. I have divided the circle into 4 quadrants. This is the radius from the center to the circumference. That's the circumference of a circle. First quadrant, second quadrant, third quadrant, and fourth quadrant, starting from 0 degrees to 90 degrees, 90 degrees to 180 degrees in anti-clockwise direction. These are positive values of the angle, and 0 to minus 90 degrees, minus 180 clockwise direction. With the protractor, I'm dividing the circle into 12 equal parts. I'm only going to do the top part so I can extend the line from circumference to circumference. I can get the bottom part. So I'll do the top part, divided into 30 degrees, multiple of 30 degrees, so 30, 60, 90, 120, 150, so I'm only marking 4 points, 30, 60, 120, and 150. So I can get the rest of the points. Now I'm going to join the lines together. This is the center. Bring your ruler to the center and bring it close to the point you want to join. You need 2 points to join a straight line because of the direction of the line. So you want to join from circumference to circumference. There you go. So I can get the bottom part. Again, the center, bring your ruler to it and set to the point you need. Circumference to circumference. Right, the other point. The point there, bring your ruler to it. And then the final point, that's 150, central point. That's it. So now I've got the points of the angles I need to get. Now I've divided the circle into 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, 360. Obviously 0. The radius is 1, so r equals 1. That's a unit circle. But the distance from there to there is 1 in terms of the radius. So what we're looking at is the x value. We're looking for the x values. These are the x here, or theta value. So this is x and this is the y value of the radius. So the radius here, the point, the coordinate at the circumference would generate its x and y values. The y value is the sine and the x value is the cosine. So we're plotting for cosine, not the sine. So from this is minus 1 and this is 0 and this is 1. So the values of the cosine will be vary from minus 1 to 1. So that will be the range. The domain is from 0 to 360. That's the domain. Right. Right, so what I've done is I've extended the line across so that we can map out what we're drawing. This is 0, and this is a half. This point here is root 3 over 2, and this is 1. That's 1. And here is minus a half. This is minus root 3 over 2. This is minus 1. The same thing here is, this is minus 1. This is minus root 3 over 2. This is minus a half. 0, a half, minus, that's root 3 over 2, that's plus, and this is 1. Now the value of cos theta we're looking at, if we project this line, that's the y value, and this bit here is the x value of that coordinate x and y. This coordinate has x and y. This is the y value, and this is the x value. Likewise, this coordinate has x and y, so that's the y value, and this is the x value. So same thing with this angle here, same thing with that angle there. So it has its y value, it's negative, and the x value is positive. Likewise with that angle, this is the x value. For 150, this is the y value, and this is the x value. We are only plotting the x value today. The x value in ratio to the radius is the cos theta. So cos of the angle theta is the adjacent of the angle theta over the hypotenuse. Hypotenuse is 1, so it's just going to be x. The adjacent is x. This is the x-axis, and this is the y-axis. So it's just x in this case. So what we're measuring is x. So to write the x value, this x value here is a half minus a half minus root 3 over 2 is this point here. So this is minus a half, and this is minus 1. Minus 1 there. Minus root 3 over 2 minus a half, 0. And this is a half, and this point here is root 3 over 2, and this is 1. But that's what we're looking at. So what's going on? The x value is going from 0 to 1, and then back to 0, and then from 0 to minus 1, and then back to 0. So if we look at the cos of 0, so this is 0 line here. The cos of 0, because we want the x value, right? So the cos of 0 is that 0, is the x value here. So that's going to be 1. So the cosine of 0 is going to be 1. So I'm going to now put the values, the degrees here, and then we can plot it. Now I have labeled the angles along here. So for 30 degrees, this is 30 here. The x value at 30 degrees, or for 0 degrees, the x value at 0 is 1. Because at 0, this is the maximum you can get, 1, 0, That's 1. So the x value is 1, so we plot 1 here. At 30 degrees, the x value is root 3 over 2. So at 30, this is root 3 over 2. So we just mark root 3 over 2. At 60 degrees, the x value is a half. At 60 degrees, the x value is a half. So we just mark a half. At 90 degrees, the x value is 0. 90 degree x is 0. At 0 degree x is 1. So 90 degrees x value is 0. At 120 degrees, x value is minus a half. 120 minus a half. At 150, the x value is minus root 3 over 2. This is minus root 3 over 2 here, that line. So this is 150, so just mark it. Remember, the x value is what we're looking at. We're moving in the x bracket, x direction, back and forth. So it's a repetitive motion, which we then call periodic motion. About the origin is the main point. Then we go to 180. 180 is minus 1. So that's minus 1. Then we're coming back down, aren't we? 210 root 3 over 2. Then 240 is minus a half. So that meant if you put in your calculator, cos 240, so let's just try that. So here's your calculator. If you plug it in there, just put it on, cos 240, you're expecting it to be minus a half. Okay. And then you go back from 240, you want to go back to 270. 270 is 0. That's 0 there. For x is coming back to 0. And then you're going back from 0 now to 300. So x is going to 300, so that's a half. And from 300, you're going to 360, 330. That's 330 here. So that's root 3 over 2, positive. And from 330, you're going to 360, and that's 1. X is 1 here. So what we've just done is move from the x value of 1 to 0, 1 to 0, and then 0 to minus 1, 0 to minus 1, then back from minus 1 to 0, back from minus 1 to 0, and then from 0 back to 1, from 0 back to 1. So that's what we called one complete cycle. And therefore the wavelength, the length of this distance between this and this is called one wavelength. We have one, let's just draw the curve here. So let's sketch this curve. The curve is going to have a turning point here. That line is coming down. So don't use pencil to draw your graph. Always don't use pen to draw your graph. Always use pencil. Because like that, if you make mistakes, it's very difficult to clean it up in the exam. I'm just doing this to make it colorful so you can see the color. Right. It's not meant to be perfect. It's just meant to show you the idea of what's going on. Okay, so that's the graph. This point here in physics, if you do physics, that point is called the trough. So that point is called the trough. or we call it minimum. It's also the turning point because there's a turning point there. And here is the crest. That's the crest. Or sometimes you call the maximum. So that's the maximum in maths. Physics crest. That's another crest there. That's the maximum. The distance between the two crests is called one wavelength. So that's the distance between here and there is called one wavelength, or the distance between two trophies and one wavelength. So this is one wavelength. The f of theta equals cos theta is a periodic function because it repeats at every 360 degrees. So 0 to 360, another repeat from 360 to 720 degrees. So it just repeats at every 360 degrees. So cos theta or cos x equals cos theta plus 360 degrees because it repeats every 360 degrees, which will be also equal to cos theta plus 720 degrees. So there's a difference of 360 here, and that becomes cos theta plus 360 degrees n, where n is an integer. And you say if you want to find the value of cos 60 degrees, you know cos 60 degrees is a half. But if you then extend the line, it's not just a half give you 60, but a half also give you 300. So it will be within that domain of 0 to 360, I can get two halves. So one half and another half at 60 and at 300. What about, say, how many 30 degrees? I can get two value for 30 degrees, one at 30, which is root 3 over 2, and one at 330, again root 3 over 2, in the range, in the domain of 0 to 360 degrees, because the x-axis are called the domain, and the y values that you get, or the function that you get, f of theta, is called the range. So this is, I'm plotting the range, and this is a domain, and then that's the range. So for 30 degrees, there are two values you're going to get. At 30, I get root 3 over 2, and I'm going to get at 330, I'm going to get root 3 over 2 as well. But if I'm looking at domain of 0 to 180, I'm only going to get just one root 3 over 2 because it's out of domain, the other one. This graph is actually symmetrical about the y-axis. So it's symmetrical. That means if you flip it like that, you get the same thing on the left hand side of the graph, which is what we're going to plot now. So when we plot this, we're going to get the symmetrical value and data here. So that's what we're going to plot now. But it is symmetrical about the y-axis. So that's the y-axis, if you like. The y-axis is the f of theta. So y equals f of theta. Now we're going to plot the left-hand side of the from 0 to minus 360. We've plotted from 0 to 360 degrees. That's what cosine graph looks like. 0 degrees is 1. So we start with 1 here. So that's 1. Now I'm going to go for minus 30 degrees. Minus 30 degrees is this, 330. That's minus 30 degrees. So I'm going back this way, right? 0 degrees, minus 30, because if you trace it down, that's minus 30 degrees. So I'm going from 360 now, if you like, or 0 to minus 30. And that's plus the value of x we're looking at. It's root 3 over 2. So this is root 3 over 2. This is 30 here. So that's root 3 over 2. Then I'm going to 60 here because I'm going back down. So that's a half. Then I'm going to 90. So that's 0. Then I'm going minus 120. So that's minus a half. Minus 150. That's minus 150 here. That's 150 is minus root 3 over 2. So that's that one here. And then from minus 150 to minus 180. So that'll give me minus 1. Because that's minus 180 here, minus 1. And then I'm coming back down again to, so from minus 180 to 210. So 210 minus 210 is that one. So minus 210 is here, minus root 3 over 2. So I'm coming back down. Minus 210 to 240. Minus 240 and minus 240 is a half. Then minus 240 to minus 270. Minus 270 is 0. Minus 270 to minus 300. So minus 300 is now in the positive side of x. So that's positive x, a half. So that's a half here. Then minus 300 to minus 330. Again, that's root 3 over 2 for 330. And minus 330 to minus 360 is minus 1. So now we've done that. So the next thing is to put the graph together. So you can see if you bring it close together, you can see if you take away the circle and bring it, you're going to get the continuous wave. So I'm going to just draw that like that. Don't use pen to draw your graph, always use pencil. It's a bad idea to use pen. I'm only using pen because so many years of experience, and yet I still make mistake. So it's to do with, sometimes it's confidence and sometimes it's just overconfident and then you lose it. Life is unpredictable sometimes. You just don't know what's in the box of chocolate. There you go, my mistake. There we go. Again, we've got a trough here. So that's a trough. Or you can call that minimum. That point here is, if you do physics, trough, or we call it minimum in maths. So that looks like quadratic graph from there. From there, not the whole thing, but so here is minimum, and that's the crest. Crest or maximum. Another crest there. And again, you can see it's symmetrical. If you reflect that to there, it's exactly the same. So it's symmetrical about the y-axis. And that's how you draw the graph of cosine theta or cosine x. Just to make this clear, because of the green color might be difficult to see, cos theta equals cos of theta plus 360 degrees, and that is also equal to cos of theta plus 720 degrees, because it's repeating at every 360 degrees. It's periodic, that's what that meant. And we can write a general form for that. So that will be cos theta plus 360 degrees n, where n is an integer. An integer means it could be a positive number, whole number, a negative whole number, or zero.